So when we started off this whole course, this semester, we said that one of the things we wanted to look for, it was maybe a week and a half ago or something like that, we said that, well, we might kind of have an idea by now of what a matrix is, but we really have no idea how to manipulate them. How do I add two matrices together? How do I multiply them? And we've been learning that for like a few lectures by now. And our goal was to achieve some sort of rules in the similar way that we have in with real numbers, right? We had said that, well, we all know something like that. X plus y equals y plus x for all x and y's in the real. Oops, that's funny. Right, well, in R. That's all gone by now. But for example, there's a commutative law for addition in the real numbers. So we knew that, and then we said that we'd be trying to look for the equivalent for matrices. And we've reached that goal in the sense that we actually know most of the statements here, or we have all the tools to prove them at least. So this is a list of the properties of matrix arithmetic. For example, you have that a plus b is equal to b plus a. At least now we know how to add two things, two matrices, and it says up here that, well, we have to assume that the sizes of the matrices are such that for each of these guys, the indicated operation can be performed. So here a and b would be equal in size, so I can add them, and I'm stating that a plus b is actually equal to b plus a. We might have seen this specifically in the lectures up to now. Maybe we've come across two matrices and we've added them, and we might have realized that, oh, it looks like it commutes. And then we've got the associative law for addition. You've got loads of them. Some are for multiplication, some are for multiplying by a scalar. So this is a set of rules that are very handy, very useful. One thing you should notice is there isn't a commutative law for multiplication. There's commutative law for addition, associative law for addition, and then, oh, we skipped right to associative law for multiplication. Well, you should know that. We've seen that a number of times by now. A times b is not equal to b times a. We've seen this. Okay, but as I've said, well, okay, this is a list of statements. This is great. This is very useful. And we kind of know how to do additions and multiplication by a scalar, but I should really go about and prove all of those things. It's a theorem, it's a statement, there are a number of laws, so they need to be proven. Each and every one of them would need to be proven. I'm not going to do this right now, there's a lot. In your book there's a proof for D. I think you are absolutely able to do H, and what I'm going to do right now is do A, prove A. See that A plus B is equal to B plus A. Let's try and see that.